Welcome, my name's Damien, Application Engineer for SolidTech. Today I'm going to talk about how to make a chain feature to follow a particular path. So in this case you'll see I have the finished product including an outer link assembly and an inner link assembly, and they've been patterned around a curve. So we're going to show how to build this. Okay, so we're going to start with a part. Okay, so what I've got in this part is a really simple sketch to start with. Well, not that simple, but simple enough. So this shows my two sprockets. I have a straight line at the top. I've added a split entities feature in here to make sure that I end up with a another point here. Okay, and I've done a number of equations. So this controls the size of my sketch, and I can tweak my variables. Down here you'll see I have two lines that have been dimensioned. This one uses an equation called a global variable, which is the overall length of my model, which I want to be 2250. Okay, so this one down here is basically an indicator of the total length of my chain. So it has the equation of adding this dimension to this dimension to this dimension to this dimension. Okay, so that is the total length of that line. So I can see I have adjusted it accordingly, so I have the right amount. Okay, so you can draw that however you like. The important thing to determine is the overall length of the line. So you can see my total length 2227.52. Plus that little bit there, 2250.02 exactly. That's all that's doing, is just a means to give me a length to control. Okay, so how do I get my links? So the idea is that we're going to start with an assembly, and on here I'm going to mate one link of each. So we're going to come in there and drag in our outside link, okay, and our inside link. So these are just two sub-assemblies being pre-drawn. This one here you'll see has a sketch that's currently hidden, and I'm going to mate this onto here. Pretty straightforward. And then all that's left to do is make sure that it's parallel with the other planes. And we get the same for top plane, and this line will make those parallel too. Okay, and we're going to do the same in here for the second piece, and this is also going to be mated parallel. And lastly, top, and this will be parallel. So pretty straightforward. All I'm doing is making a single component, but we're going to take advantage of a component driven pattern. So I'm going to do it inside of my part. I want to pattern these at their spacing, and you'll see they're spaced at 22.5 between centers. Okay, so that's been determined. It's going to fit my overall length. Okay, so all that's left to do is come back to my feature. I've made two simple surfaces. In fact, we'll remake these. What I've done is drawn two sketches on the front plane, and we've used the surface extrude. Okay, and the same for this one, surface extrude. I'll make this one a little bit smaller so it's easier to distinguish. Okay, now what we're going to do is pattern these around my curve. Okay, so we're going to select the sketch and go to our features and use a curve driven pattern. So this way I can pattern the actual surface body. So this is like a template going to allow me to pattern against it. So there's some options in here. I've told it that I need 50 instances. Okay, but later we can link this to an equation that's going to divide the length of the belt. Okay, you can also make sure you've got offset curve if you've done it on the top, and you can also make sure it's tangent to the curve, not aligned to the original seed feature. Okay, same command again. This time we're going to do it for the other body. So bodies to pattern. Okay, so these surfaces can be used to drive, and they're quite efficient from this point of view. Okay, so just quickly looking at our equations, you'll see in here, other than my overall length, which has an issue, we can see I have my link distance set to 45, which is my total length, and I also have a number of instances linked to 50. So we can come into those two pattern features and we can make that equal to number of instances, which already is, so that's good. This one isn't, so we're going to say that one is equal to number of instances. Okay, so we get a nice simple equation. So now back in my assembly, all that's left to do is do what we call a feature driven component pattern. So we're going to say I want to pattern this entire outer link assembly driven by a feature associated with the first surface. And we can do the same again for the inside link driven by the smaller surfaces. Then all that's left to do is hide my surfaces and hide my sketches. And the advantage of this is that it's going to be parametric, so if we come into that sketch and make some changes to my model, we can update it accordingly. So we can make that 320, for example. You'll see that if I do a rebuild and come back into my sketch, you'll see the overall length obviously not equal anymore, so we need to tweak some of these values until it matches something appropriate. So maybe what we do is we want it to be a little bit shorter, so 798, rebuild 760, obviously that's way too much, 790. So we're getting closer to matching this. So it's an iterative process, and I'm sure a macro could be written to get a little bit closer. Okay, so we're 3 millimeters out from that overall belt length that we chose. But we have changed the size of my diameter, and my assembly will update accordingly. Obviously that 3 mil will be spread out all the way around my structure, so it'll be hard to see it anyway. Thank you for listening.